before I talk about the warm-up, I actually want to take a minute and explain one more time why we have the AC method. Because if I show it to you, the explanation of it, it might help you remember the steps. So sort of put these things on pause for a minute. I'm actually going to start with a simple, like FOIL or double distributive property problem. Like let's say I have this, okay? And I'm going to multiply those out. I would do x, I would distribute the x through, and I would get 2x squared minus 3x, right? And then I would distribute the 5, and I would get plus 10x minus 15. What would be my next step after here? Right, combine the two x's. This would give me 7x. And then I would have the 2x squared and the minus 15. What you're doing in the warm-up is this process just backwards, right? You're starting here, and you're saying, so like up here, I got the 2x squared from doing 2x times that, right? And I got the negative 15 times the 5 times negative 3. So when I'm saying what multiplies to 2 times negative 15 and adds to 7, you would say 10 and negative 3. Where do you see 10 and negative 3 already? Right here. You see that? So this work, when I'm asking you to do the times AC and what adds to B, it's just going backwards. And so then I would rewrite 7x as 10x negative 3x, bring down that 2x squared, bring down that negative 15, and then I would do factor by grouping. This first group has 2x in common, leaving me with an x plus 5. This next group has a minus 3 in common, leaving me an x plus 5. And then what do they have in common? The x plus 5, and then 2x left over, and minus 3. Right? X plus 5, 2x minus 3. So just as, so really the work here is that splitting the middle term. Right? So when we go back to the warm-up problems, I say, okay, so and this is why it's called the AC method, because you start out by multiplying the A value times the C value. Remember standard form, this is AX squared plus BX plus C. So 3 is A, 12 is C. When you multiply, you get 36, and you wanted to add up to the middle term. Where did y'all get that multiplies to 36 and adds to negative 9, negative 4? So you're just rewriting the negative 13 as two things, negative 9x, negative 4x. And then you bring down the 3x squared, and you bring down the positive 12. You do your factor by grouping. 3x is the GCF in the first group, leaves you x minus 3. Because the second group starts with a minus, you're going to use a minus for your GCF. Okay? So it's minus 4 times x, and you had a positive 12, you divide out negative 4, that gives you negative 3. And then they have x minus 3 in common, leaves you a 3x here, and a minus 4 there. Now on number 2, did anybody pull out a GCF first? Yes. Always check for, because what would have happened if you had, we can do the GCF at the end, okay? If you didn't, you just have to notice it later. If we had done it in the beginning, and you don't have to write this down, if you, I just want to show you. If we did it first, our numbers would be smaller. We would do AC method now on this, and it would just be easier. Okay, but that's not absolutely necessary. I'm assuming y'all did not do that. I'm assuming that you started here. 12 times negative 6 is negative 72. You want to add to negative 21. Now it's going to take a little longer to figure out the combination because the numbers are bigger, but what'd you come up with? 24 and 3, which one's negative? 24, right? Because it has to add to negative 21. All right, so then what we do is we rewrite the middle term with those two numbers, negative 24x plus 3x, bring down the minus 6, bring down the 12x squared. Oh, and then you do your factor by grouping. The GCF in this first group is 12x, leaving me x minus 2. In the second group, it's 3, leaving me x minus 2. And then, did you stop here? Okay. The reason why I would circle this is because it's not factored completely. This second group right here, what's a GCF? What do they? 3. So when you pull 3 out of that group, you're left with 4x plus 1. And then you need that to bring down the x minus 2 as well. So if you didn't pull the 3 out in the beginning, you would just have to recognize to pull it out at the end is all. So always in your mind be checking if anything has a GCF that needs to be factored out. All right? Oh, questions? No, not quite. Although I myself am feeling pretty tired. This is my 6th class. And I'm feeling well, let me pause the video. Lesson done, so give me done. Okay. We're kind of going to do the worksheet backwards than the way it's presented. We're going to get to this table in a minute. I want to just first talk about what we're learning today. We're learning difference of two squares. We are still factoring, so our goal for the lesson is to still get something in a group times something else in a group. Okay, that's what it means to factor. Okay? Yeah, something times something, and it's going to be in parentheses. The method today is called difference of squares. Difference in math meaning you're subtracting, and squares meaning we're talking about perfect squares. Can you give me an example of something that's a perfect square? 5 times 5, which is 25. 4, 4, right? So, like 16, 8 times 8. So, like 16 minus 25, these are two perfect squares that are being subtracted, okay? The only difference is in our problems, there's going to be some variables as well. So when you have the case that two things are being subtracted, so I'm going to skip down here to this formula. So there's your 4 squared and your 5 squared right there, okay? What you do is follow this formula. You take the square root of a minus the square root of b, and then you do the same thing but with a plus version. So like let's say I had these perfect squares. Let's say I had x squared minus 25. Well, what is the square root of x squared? What times it's x? And what's the square root of 5? I'm sorry. Yeah, okay, thank you. The square root of 25 is 5. You would just make a minus version of those and a plus version, and that would be it. That's factored form. Okay. If you were to multiply that back out, what happens is, because like this is a binomial, right? It seems like when you get your answer should have 3 terms instead of 2, but what happens is the middles drop out. So when you do FOIL or double distribute, you get x squared plus 5x minus 5x minus 25. What happens to those two middle terms? Yeah, they drop out, leaving you x squared minus 25. So that pattern happens only when you're subtracting two perfect squares. Right, so what we're going to do is spend some time practicing how to take the square root of stuff. All right, and so we're going to, you have a table there with perfect squares. It's the second column. We're going to break this table up into, there's actually 3 sections. There's this first section is just numbers. The second section is just variables. And then the third section is numbers with variables, okay, coefficients and variables. So for the first thing, 25, it's asking, is that a perfect square, yes or no? What would you say? Yes. And what's the square root? Okay. Is 15 a perfect square? No. Okay, so that's, we can't square root it. 22? Nope. 8? No, right? Because nothing times itself will give you 8. 1? Yes. What's the square root? 1, 4. All right, good. All right. So that's practicing with just numbers. Let's talk about variables, though. Do you think x squared is a perfect square? Yes. What's its square root? Right. What about x to the 5th? Why not? It's odd, right? There's nothing times it's, because don't forget, when you're multiplying stuff with exponents, you add the exponent. So x1, x4 would give me x5. x2 times x3 would give me x5, but there's nothing times itself. That would give me 5, because 5 is odd. Well, 2.5, but we're going to deal with integers only. So this is a no. What about m to the 8? It's a yes, because what kind of number is 8? It's not odd, it's even. What times itself would give me m to the 8? M to the? Well, I just need 2 of them, because it's square root. 4. 4 and 4. M to the 4th times m to the 4th gives me m to the 8. So even though here, when 8 was just a number, we'd say that's not a square root. But when 8 is the exponent, we say, yes, this is a perfect square, and the square root is m to the 4. What about y to the 1? Is that a yes or no? Yes. No. It's a no, because what kind of number is 1? Oh, you're right. See, this is where we have to keep our minds right? Because 1 by itself is a perfect square, but 1 as an exponent does not have a perfect square. Because no two things will add up to 1. Not integers, anyway. And then here, for this section, in order for that entire thing to be a perfect square, both the number, or coefficient, the number and variable have to be perfect squares at the same time. If either one fails, then the whole thing fails. So would you say yes or no for 2x squared? No. Which piece fails? The 2 or the x squared? The 2, right? What about 4x squared? Yes. Absolutely. And what's its square root? 2x. 25y? Yeah. What's its square root? 5y squared. 8y to the 8? No. Which part fails? Which 8? The first one. The coefficient one, right? Yeah. Because y to the 8 works, but 8 fails. All right. So that was our practice taking square roots. So now we'll use those skills by doing the formula on some practice problems. I'm going to scroll down. Does anybody need this up anymore? All right, so number 1, I need the square root of the first thing and the square root of the second. What's the square root of 64y squared? 8y. What about 25? I'm going to make a minus version and a plus version, and I'm done. Isn't that bad? I want you to do 2, 3, and 4, and then we'll talk about it. Talk about it, talk about it, talk about it. 5 and 5. Okay. Number 2. What'd you get?
11n minus 1.
11n minus 1. Yes. Yes. 11.
You got that, Krislan?
I got it, yeah.
Okay. What'd y'all get for 3?
9y minus 4. 9y plus 4.
9y minus 4.
My God.
What'd you get for 4?
12x minus 7.
Ooh, what kind of 7? Who got NA for 5 and 6? No. All right. So for 5 and 6, you have to pull out a GCF first. That's why I told you I'll just do 1, 2, 3, and 4. But now let's talk about 5 and 6. What's the GCF in 5? Okay. So then what's left over? Perfect squares, right? So how would you do that? X squared minus 4. That's two perfect squares being subtracted.
3x plus 2 minus 2.
Yes. It doesn't matter which order the minus and plus go. Okay, you do 6 like that. Pull the GCF out, then do difference of squares. And raise your hand when you're done. What was y'all's GCF? 5. So that leaves me 9m squared
Yes.
minus 4.
Let's go, baby.
So what's the square root of 9m squared?
3m.
The square root of 4. 2. So you need a minus version and a plus version. What have I forgotten so far in my answer? The 5. Okay, we have a practice thing for this, but we did not get to it in my other classes, so we're not going to get to it here. We'll do it on Monday. I don't know how we went so fast, you guys.
Because we're in a fishing